In this video, we're going to talk about solving rational equations, which corresponds to section 7.6 in your textbook. So a rational equation is just an equation that involves one or more rational expressions. Now remember, rational expressions are those fancy-looking fractions that involve polynomials. So you might have something like 5 over x plus 2 plus 7 equals, that's not a very good equals, we'll fix that here. That's going to equal, say, 1 over x minus 1, or something like that. So we have a rational expression here, we've got a rational expression here, and then we've set it all up in a big equation. And we know that because there's an equal sign. So when we're solving rational equations, we're going to use the least common denominator as a multiplier on both sides of the equation in order to clear the fractions. Sort of like what we did in the last section where we were dealing with complex fractions. We cleared the fractions by using the LCD in one of our methods. So first things first, let's look at this one, 3 over x, and then plus 1, that equals x over 4. The first question is, of course, what is the LCD for all of these fractions? Well, the denominator here is x, the denominator here is 1, and the denominator here is 4. You can get a common denominator if you multiply all denominators together, 4 times 1 times x, which in this case is 4x, and it just so happens that that's the least common denominator in this example too. If you don't use the least common denominator and you just use the common denominator or a common denominator, you'll just have to do some extra simplifying as you work out the problem. It's not actually a big deal. So we're going to multiply both sides of our equation times 4x. And then remember, on this side, since I have two terms, you can't really see them squeezing that in there, you have to multiply 4x times our 3 over x and 4x times 1. And then that's, of course, going to equal our 4x times x over 4. That's not a very good 4. Let me fix that. Okay. And then we simplify first. And our goal, remember, is that we have eliminated all of our fractions. Okay. So in this case, 4x times 3 over x, this would give me 12x over x, which is just 12. This is 4x times 1, so that's just 4x. And then here I have a 4x times x over 4. Well, this is going to give me a 4x squared divided by 4, so that's just x squared. Well, it looks like what we have now is a quadratic expression, and in order to solve this, we have to set it equal to 0. So I'm going to subtract 12, and I'm going to subtract 4x to the other side, minus 4x and minus 12. So what I get is 0 equals x squared minus 4x minus 12. Question is, can you factor that? And in this case, yes, indeed we can. This factors into x minus 6 and x plus 2. And then we solve it. X minus 6 equals 0, and x plus 2 equals 0. So we come up with a solution, two solutions actually. One of them is x equals 6, and one of them is x equals negative 2. Now, when we're dealing with, I guess I wrote it, I don't have to write it again. When we're dealing with rational equations, actually most all equations in math, we should check our solutions in our original problem to make sure that they work. It would be a problem when you consider this original equation, it would be a problem if we came up with an answer of x equals 0, because 3 divided by 0 is undefined. So that's why we need to check and make sure that either of the possible solutions do not cause us a situation where we end up with something divided by 0. So the first one here, if we're going to do our little check step, I'm going to write check just so you know this is where it's happening. So 3 over 6 plus 1, does that equal 6 over 4? That's the question. Well, 3 over 6 is 1/2, plus 1 is 1 1/2, or 3/2. 3/2. And of course 6/4, that reduces to 3/2. And so that checks off just fine, and we're good to go there. So now let's look at this one. Well, 3/2, and we add 1 to that. Does that equal -2/4? Well, 3/2, this is -1.5, plus 1 leaves us with -1/2, and if we simplify -2/4, that is indeed -1/2. So that checks off just fine as well. So again, checking those proposed solutions to make sure that we're not dividing by 0. That's really important. Okay, let's take a look at this example. First things first, what is the LCD here? I like to write it down so I don't forget it. Okay, so I have 1/x minus 1 plus 2/x equals x/x minus 1. So it looks like my least common denominator is going to be x times x minus 1. Okay, so then I'm multiplying. I set up this page so it's a little bit challenging. I'm multiplying both sides of my equation here, this side and this side, by x times x minus 1, with the intent of canceling out my fractions so I don't have to deal with the denominators. So when I multiply x times x minus 1 times 1/x minus 1, the whole point is that my x minus 1's cancel. So I'm left with 1 times x, which is just x. In this second fraction here, I have 2/x. I'm multiplying times x minus 1. Again, my x's cancel, so what I'm left with is 2 and my x minus 1, so I'm multiplying those. And then that equals, don't forget your equal sign, that's important. I have x/x minus 1, and I'm multiplying that times x minus 1. The x minus 1's will cancel. I'm left with x times x, which is x squared. So this is x plus 2x minus 1, which is really 3x minus 1, and that equals x squared. Excuse me, oops, you caught my mistake. That's really a minus 2. Okay, so now I'm going to move these to the other side of the equation. So I'm going to subtract 3x because we can't solve until it's set equal to 0. So I have 0 equals x squared minus 3x plus 2. Can you factor that? You bet you can. So I have 0 equals x minus 2 and x minus 1. So x minus 2 equals 0. This gives me a solution of x equals 2. And x minus 1 equals 0. This gives me a solution of x equals 1. Now, before we can move on, we need to check. Okay? So in this process of checking, I'm putting my solutions back in. So I have 1 over 2 minus 1 plus 2 over 2. The question is, does that equal 2 over 2 minus 1? Well, what is 2 minus 1? That's 1. So I have 1 over 1, which is 1, plus 2 over 2, which is 1. And 2 over 2 minus 1, this becomes 1, so 2 over 1 is 2. 1 plus 1 is 2. We're good to go there. Now when I check my other solution, I have 1 over 1 minus 1 plus 2 over 1. And the question is, does that equal 1 over 1 minus 1? What happens when I do the 1 minus 1 here? I get 1 over 0. That's a problem. This is undefined, which is not appropriate for math. So what we say is this solution here is extraneous. And it's possible, even though we solved it, even though we did all the right steps all the way through, we still came up with an extraneous solution. And it happened back when we multiplied our x times x and we got an x squared. No worries though. So we really have one solution, which is x equals 2, and our solution of x equals 1, it didn't work for us. Okay, so let's go on to one more type of problem that you're going to see in this section. And that is where you are solving an equation for a specific variable. In this case, I have 3 different variables, and I want to solve the equation for y. We're going to use the same process of solving as our previous equations, where we look at the LCD. So in this case, the LCD is x times y times z. So we're going to multiply both sides of the equation times the LCD, which is x times y times z, in order to eliminate our denominators, x, y, z. Okay? So when I multiply this first 1 over x times x, y, z, my x's will cancel and I'll be left with just y, z. And then when I have 3 over y, when I multiply times x, y, z, my y's cancel that time, and I'm left with 3xz. And then on this side, 2 over z times x, y, z, my z's cancel, and I'm left with 2xy. My goal is to solve for y, so I need to move everything that has a y to one side of the equation. So I'm subtracting my yz here. Okay? So now what I'm left with is my 3xz, and that is equal to 2xy minus yz. Since both of these expressions have a y in them, I can factor out the y, and then I'm left with 2x minus z. Okay? This guy over here, he stays as the 3xz. And I'm almost done now. Now all I need to do is divide by the 2x minus z, which is keeping my y from being by itself. 2x, oops, not z. Where's my eraser? 2x minus z. So now what I have is y equals 3xz divided by 2x minus z. Okay? So even though I'm not actually solving, I'm not getting like y equals 2 or x equals -5 or something like that, I still solved for y. In this case, I got y by itself. I solved this rational equation by multiplying both sides of my original equation by my LCD. Okay? So that's how you solve rational equations. Don't forget to look for that least common denominator. Keep up the good work, and I'll see you in the next one.